Hello there, and thank you for joining me today for this lesson about angles of rotation. We are going to discuss what angles of rotation are. We are going to sketch some. We will identify what are called coterminal angles. And finally, we'll talk about a new unit of measure for angles, and we'll practice sketching angles using that unit of measure. So when you've worked with angles in the past, you've probably worked with them, within polygons or maybe between parallel lines or intersecting lines. But you maybe haven't worked with many angles that are more than 180 degrees. And in this new chapter where we start looking at some trigonometry stuff, we're going to work with angles that are more than 180 degrees. And a great way for us to visualize them and work with them is to sketch them as angles of rotation. So an angle of rotation is sketched on the XY coordinate plane, where the vertex is right at the origin. The angle starts at the initial side, which is always the right side of the x-axis, the positive side. And then the angle itself is going to rotate either up if it's a positive angle, or over here down if it's a negative angle of rotation, until we have rotated that many degrees. And then wherever that angle ends up is called the terminal side, where the angle ends, where it terminates. When we sketch these in, we don't have to be exact. We don't have to get out a protractor and measure, but we should be fairly accurate. And one thing that can help us be fairly accurate is to use some benchmarks. So what I mean by that is, if we started on the initial side and we rotated up here, that would be 90 degrees. So every quadrant is worth 90 degrees. So with that in mind, if every quadrant is worth 90 degrees, then half of the quadrant would be 45 degrees. Right? So if we had to sketch something like 30 degrees, that would be less than half of a quadrant. And these aren't exact, 90 degrees was, but other than that, we just have to be close enough, and we can use these benchmarks to help us with that. So let's sketch some angles. Let's start here with positive 120 degrees. Our vertex is here at the origin. Here's the initial side of our angle. It's a positive 120, so we're going to rotate up towards the positive y values, and let's use our benchmarks to help us. This far would be 90. To get to 120, we'd have to go 30 more. Well, we talked about how halfway through would be 45, but we only want to go 30, so we need to go less than halfway. And if you took a protractor and measured, you would find that this likely isn't exactly 120 degrees, but it's close enough. Close enough to get a good visual sense of what this angle looks like. Let's try negative 45. Here's our vertex. Here's the initial side. A negative angle is going to rotate down. 45 degrees would be halfway through this quadrant. Here's negative 45 degrees. Positive 270. Here's our initial side. That's 90. 90 more would be 180. 90 more would be exactly 270. So there's the terminal side of our angle right there. This was 270 degrees. 240 degrees, here's our initial side. Here's the origin. 90, 180. We need 60 more to get to 240. Well, 60 is more than 45, which is halfway through, so we got to go more than halfway through this quadrant. We're going to be closer to 270 than we would be to 180, and my sketch reflects that there. 315 degrees, rotating in the positive direction. Here's 90, 180, 270. 315 would be 45 more, which is halfway through that quadrant. Last one, negative 90 degrees. Here's our initial side, rotating down because it's negative. Negative 90 would take us right there. Here is negative 90 degrees. The idea is not to be perfect. The idea is to be close enough. I want to point out this pair right here and this pair right here. Notice that although the angles were different, the terminal sides were the same here and here and here and here. These pairs of angles, the pair circled in blue and the pair circled in purple, are what are known as coterminal angles. These are angles that share the same terminal side. So graphically, if you sketch an angle and the terminal side ends up in the exact same place, those angles are coterminal. But it's possible for us to calculate coterminal angles as well by adding or subtracting 360 degrees, or 2 pi radians, which we'll talk more about later. We could add or subtract 360 degrees multiple times to generate more and more coterminal angles. It's like spinning around once, but then spinning around again and again and again. You could be facing the same direction, but you've spun around multiple times. In other words, added 360 degrees multiple times. These are beneficial when we start working with some large angles and we don't want to sketch, say, an angle of 1200 degrees and go around that many times. So instead we find a coterminal angle with it that's smaller and easier to sketch, more efficient to sketch, and then we can analyze the behavior of that coterminal angle. So let's do one example. I'm going to skip a little bit to try to keep this video as short as possible. The directions say find one positive and one negative coterminal angle for each. 120 was already spoiled back here, so let's talk about negative 450. I could sketch this out, but the idea is that we don't have to yet. I can find a coterminal angle by spinning around completely one time, in other words, adding 360, and if I do that, I'll be at negative 90. So here's a negative coterminal angle for negative 450 degrees. Now I haven't found a positive coterminal angle yet, so I better spin around one more time, add 360 again. Now I have a positive coterminal angle. For what it's worth, you could have found another negative answer by subtracting 360, spinning around the other way, and you would have got negative 810 degrees. One big idea here is that there's not just one set of coterminal angles. We could continue to add 360 or continue to subtract 360, and we'd get more and more answers. The directions here said find one of each, and I did that. So we've talked about angles of rotation, we've sketched a few, we know what coterminal angles are. Right now I want to talk about a new unit of measure for us. And up to this point you maybe have specifically thought of angles exclusively in terms of degrees. Well, there is another unit of measure for angles known as radians. And the radian describes the measure of a central angle whose intercepted arc is the same length as the radius of that circle that it's inside. So on the screen, I've just got a couple of images that kind of show that. Each of those angles there measure 1 radian because they generate an arc that's the same length as the radius of the circle. I could tell you exactly how many degrees 1 radian is, and we could talk about that. But it's going to be more helpful for us to know other benchmarks in terms of how degrees relate to radians. So I have one of those benchmarks on the screen here. It's kind of like how 12 inches equals 1 foot. That can help us to convert back and forth, right? Well, as it turns out, pi radians is equivalent to 180 degrees. And maybe pi isn't a big surprise because, pi comes into play with circumference and other aspects of circles. So maybe that doesn't surprise you a whole lot. But there's one conversion factor that will help us out. Knowing that pi radians is equivalent to 180 degrees is helpful. I'm going to write down a couple more then that we could find based off that. 2 pi radians then would be 2 times 180 or 360 degrees. So one trip around a circle, all the way around 360 degrees, is 2 pi radians. It's also helpful for us to know what half of this relationship is. So if you take pi and cut it in half, take 180 and cut it in half, you'll get 90 degrees. So 90 degrees is equivalent to pi over 2 radians. And there's others, but I'm just going to add one more here. If you cut in half again, you'd get 45 degrees. So pi over 4 radians is equivalent to 45 degrees. I should have the label radians for each of these, but I got a little bit lazy there. You don't have to know this definition in and out, to be honest with you, at least for my class, but you need to know some of these benchmarks, and we're going to practice using them here in a moment. In fact, right now. So one of the skills we need to take away from this lesson is converting back and forth between degrees and radians. You could probably picture what a 45-degree angle looks like pretty quickly, but if I ask you to picture what an angle of pi over 4 radians looks like, you'd probably have to convert that to degrees first and then visualize it. Eventually, we might have enough practice where we can take radians and picture that right away, but we're just starting out, so we should be able to convert to degrees to get a better sense of them. So on the screen in green here, I've got some conversion factors written down. When we convert from degrees to radians, based on the relationship in orange there, when we go from degrees to radians, we're going to multiply by pi over 180. When we go backwards from radians to degrees, we're going to flip that and multiply by 180 over pi. With enough practice, this won't be a case of memorizing that. You'll just have enough repetition where I think you'll know to do it. So let's take negative 450 degrees and let's convert that to radians. So we're going in this direction now, degrees to radians. So we're going to multiply by pi over 180, and we're going to simplify. So when we multiply by pi over 180, and you can put this over 1 if it helps, you can either multiply straight across and then simplify, or maybe simplify right now. For example, I know that they're both divisible by 90, and if I divide by 90, this one would turn into 2, and this one would turn into negative 5. Now when I multiply straight across, I'll have negative 5 pi on the bottom. 1 times 2 is 2. And I can't simplify that fraction anymore. And when we give angles in terms of radians, we often like to leave them in terms of pi instead of calculating them as a decimal, which would have to be rounded. So negative 450 degrees is equivalent to negative 5 pi over 2 radians. Now let's go from radians to degrees. So we are going now in this direction. So we will multiply by 180 over pi. So I'll get that set up. And you could multiply straight across and then simplify, or you could simplify now. We've got pi's that will cancel. I know that 180 is divisible by 4. So if I divide by 4, that becomes a 1, and this would become a 45. And now when I multiply straight across, I've got 3 times 45, and on the bottom, 1 times 1. 3 times 45 being 135. So 3 pi over 4 radians is equivalent to 135 degrees. There will come a time, believe it or not, where you have enough practice and you use these values enough where you're going to start to memorize some of them. You know, down the road, you might look at 3 pi over 4 radians and know, yep, that's 135 without having to do this little calculation. But for now, let's do that calculation until we get to that point. So we're going to finish our lesson then by kind of putting this all together. And we'll just do the first 2 examples here. We're going to sketch these angles of rotation, but this time we're giving them in terms of radians. And if you're like me, when you first start out with this, you want to convert it to degrees so you can use those benchmarks we talked about earlier. So let's take negative pi over 6, let's convert it to degrees, and then we'll go ahead and sketch it in. So here's negative pi over 6 radians. We want to convert that to degrees. Well, one trick for remembering what to multiply by, when you're going from radians to degrees, you're going to want the pi's to cancel. So I'm going to need a pi down below for that to happen. Now I can cancel my pi's. 180 and 6 are both divisible by 6, so I'll do that, simplifying. And when I multiply straight across, I'll get negative 30 degrees. So negative pi over 6 radians is equivalent to negative 30 degrees. So here comes my sketch. Here's that initial side, always in the same place. This is negative 30 degrees, so I'll have to rotate down. 30 degrees is less than 45, which would be halfway through. So I'm going to sketch less than halfway through that quadrant. Here's negative pi over 6 radians. Finally, 5 pi over 4. Let's come down here and let's convert. We'll multiply by 180 over pi to make that happen. Pi's cancel. Both of these are divisible by 4, so I will do that division. And now when I multiply straight across, top to top, bottom to bottom, 5 times 45 is 225. And down below we just have 1, so just a 1 down there. So 5 pi over 4 radians is equivalent to 225 degrees. Let's sketch in that angle of rotation. Here's that initial side. Using our benchmarks, this much is 90. 90 more is 180. 225 would be 45 more than that. So I have to go halfway through that next quadrant to get to my terminal side. So there is 5 pi over 4 radians sketched as an angle of rotation. So today, big ideas. We talked about angles of rotation. We sketched in some using some benchmarks. We talked about coterminal angles, and finally, this new unit of measure called radians. We converted from radians to degrees and actually sketched a few angles of rotation given in radians as well. This is a good start for our chapter about trigonometry. That's all for today. Thank you for watching.